Hey there and welcome. Have you ever stopped to think about one of the most incredible things your body does, like every single second? I'm talking about hearing. How does it actually work? Well, today we're going to follow the amazing journey of a single sound from a vibration in the air all the way into your mind.
So let's just start with the big question right up front. How does a simple vibration, a sound wave from a friend's laugh or your favorite song, somehow transform into a feeling, a memory, or music that you experience inside your own head? That's the puzzle we're going to solve together right now. All right, our journey begins with step one, catching the wave. And this is all about your outer ear. I mean, think of it like the perfect custom-built satellite dish, designed to scoop up sounds from all around you. And here's how the pieces work together. First, you've got the pinna. That's the part of the ear you can actually see. All those strange folds and curves, they're not random. They're perfectly shaped to funnel sound waves into the auditory canal. The waves then travel down that tunnel until, bam, they hit the tympanic membrane, which we all just call the eardrum, and make it vibrate. And right there, that's the first huge transformation. A vibration that was traveling through the air has just been converted into a physical, mechanical vibration. This is the official handoff from the outside world to the incredible machinery inside your head. So what happens next? Well, we move on to section 2, where we're boosting the signal. We're now in the middle ear, and its main job is to act like a powerful little amplifier. It takes that first vibration and really cranks it up so it's ready for the next part of the trip. To pull this off, the middle ear has some pretty specialized equipment. In fact, we're talking about the 3 smallest bones in the entire human body. They're so tiny, you could literally rest all 3 of them on the tip of your pinky finger. And here they are, the malleus, the incus, and the stapes, or as you probably know them, the hammer, anvil, and stirrup. These bones create this brilliant little lever system. So when the eardrum vibrates, it jiggles the hammer, which pushes the anvil, which then presses on the stirrup. This whole action focuses all that energy, making the vibration much, much stronger as it passes it on to the inner ear. Okay, get ready, because this is probably the most mind-blowing part of the whole story. We've arrived at the inner ear, and this is where the real magic happens. This is the moment where that mechanical signal gets translated into a language that your brain can actually speak. And the star of this show is the cochlea. Just look at this thing. It's this beautiful spiral-shaped organ that looks like a tiny snail shell, and it's filled with fluid. It might be small, but this is the biological powerhouse where the whole conversion goes down. So how does it work? Well, that stirrup bone presses against the cochlea, which creates waves in the fluid inside. As those waves ripple through the cochlea, they bend thousands of these microscopic, super sensitive hair cells. And this is the key moment. As these tiny hairs bend, they open up little channels that generate an electrical impulse. And boom, there it is, the second critical energy conversion. We've gone from a physical, mechanical vibration to a pure electrical signal. This is the universal language of your entire nervous system. The brain can now understand what's happening. So we've got our electrical signal, now what? Well, it's ready for the last leg of its journey. You can think of this next part as the information superhighway, a direct, high-speed line carrying that message straight to brain headquarters. These new electrical impulses shoot out of the cochlea and travel at lightning speed up the auditory nerve. They make a couple of quick stops at some relay stations in the brainstem for a bit of early processing, and then they arrive at their final destination, the auditory cortex, which is tucked away in the temporal lobe of your brain. And that brings us to the grand finale, decoding the message. The auditory cortex gets this flood of raw electrical data, and now it has to do the really hard work of figuring out what it all means. It has to turn that stream of electrical pulses into a sound you actually recognize. So how on earth does it do that? It's brilliant, really. To figure out a sound's pitch, like a high note versus a low note, the brain just looks at which specific hair cells in the cochlea got triggered. To figure out loudness, it checks how much those hair cells bent. And to tell you where a sound is coming from, it calculates the tiny microscopic difference in time it took for the sound to hit each of your ears. Amazing, right? And just like that, a complex pattern of electrical code becomes, while at your name being called from across the room, the punchline of a great joke, or the opening chords of your favorite song. It's an entire symphony of interpretation happening faster than you can even blink. So let's just zoom out and recap that whole journey one last time. We started with a sound wave, which was collected by the outer ear. It was amplified into a mechanical vibration by the middle ear. Then it was transformed into an electrical impulse in the cochlea, transmitted by the auditory nerve, and finally interpreted by the brain. A truly incredible five-step process, taking you from air to pure awareness. And that brings us to a classic philosophical question to leave you with. If a tree falls in a forest and no one is around to hear it, is there sound? Well, based on everything we just learned, there are definitely vibrations in the air, for sure. But without an ear and a brain there to complete that incredible journey of conversion and interpretation, can you really call it sound? It's something to think about, isn't it? Thanks so much for joining me on this journey.